A departmental head has 4 subordinates and 4 tasks for completion. The subordinates differ in their capabilities and tasks differ in their work contents and intrinsic difficulties. His estimate of time for each subordinate and each task is given in the matrix below. How should the tasks be assigned to minimize requirements of man-hours? So let's first understand what is the problem here. So consider that you are a departmental head. You have 4 subordinates, which is listed here: 1, 2, 3 and 4. Each subordinate differs in their capability. One subordinate is very quick at doing some things, the other subordinate is quick at doing some different things. Now suppose you have 4 tasks, that is A, B, C and D. Each task is different in their content, and one task may be more difficult than the other task. So here the task is to assign each of these tasks to one and only one subordinate, so that the requirement of man hours is minimized. If you see in the matrix, A has 17 in front of 1. So what this means is that subordinate number 1 will take 17 hours to process task A. Similarly, subordinate 1 will take 28 hours to process task B, 20 hours to process task C, and 28 hours to process task D. So how would you go about assigning these tasks to the subordinates? So the first step here is to express the problem into an n by n assignment matrix. So here the matrix will look something like this. And then we will note down the hours. If we were to solve this problem by observation, we would assign each task to the lowest man hours taken by the subordinate. So if we go by observation, for A the lowest number is 17, so we would do A is assigned to 1. For B the lowest is 23, so B is assigned to 3. C is assigned to 4 and D is also assigned to 4. So we have a conflict here. C and D both are being assigned to 4, and that is what we want to avoid, because the problem is that we have to assign one task to one subordinate. So while the task is to arrive at the minimum number of man hours for a task to subordinate combination, let's reduce the complexity of this matrix by deducting all numbers in a row by the smallest number in the row. That way the smallest number will become a 0, and then we can target the zeros to arrive at the optimal solution. So hence we arrive to our step 2. We will again note down the matrix. So if we go row wise, the lowest number in the first row is 17. So let's deduct 17 from each of the numbers in the row. So then our row becomes 0, 8, 9, 3. For the second row, the lowest number is 23. So let's deduct 23 from each of the numbers in the row. So our row becomes 5, 4, 0, 2. Similarly, for third one, the lowest is 14. So we have 6, 4, 3, 0. Fourth, we have 19 as the lowest. So we have 9, 6, 4, 0. So let's repeat the same steps, but this time we'll do column wise. So hence our step number 3. So we have A, B, C, D. 1, 2, 3, 4. Let's go for the first column. So we already have a 0 here, so we can just note down the numbers as is. For second column, the lowest is 4, so let's deduct 4. Column becomes 4, 0, 0, 2. For third, we already have a 0, so 9, 0, 3, 4. And fourth, again we have a 0 here, so 3, 2, 0, 0. So currently, wherever there are zeros, the task can be assigned to the subordinates. However, we need to first determine if we have reached the optimal solution or not. Since the objective is to have one task assigned to one and only one subordinate, if we connect the zeros with the minimum number of straight lines, and if the number of straight lines is equal to the number of rows or columns, then the optimal solution has been reached. But if we are able to connect the zeros with less than the number of rows and columns that we have, then we don't have an optimal solution yet. Hence, let's move to step number 4. So step number 4, let's first copy the matrix that we got in step number 3. We have A, B, C, D. Now let's connect the zeros with the minimum number of straight lines. Let's go row wise to find if there are any rows with 3 or more zeros. So we don't have any row with 3 or more zeros. Let's do the same thing column wise. So we don't have any column with 3 or more zeros. Let's try again second iteration for 2 or more. So let's go row wise. We have row number 2 which has 2. We have row number 3 which has 2. Now let's do column wise. So we have here we have 1 and here we have only 1. Now in the third iteration, let's do again row wise with 1 or more. So first we have A and then D. So here the number of straight lines is 4 and the number of rows and columns is also 4, which means that we have reached the optimal solution. Now since we already have an optimal solution, we can go ahead and assign the task to the subordinate in an optimal fashion. So hence step number 5. Let's copy the same matrix that we have. In order to determine the optimal assignments, we will examine the rows one by one, starting with the first row until a row with one exclusive 0 is found. Basically, by doing this, we are first going to assign tasks to subordinates which have only one possible best solution. Since we have then assigned the task to the subordinate cannot be assigned to any other task, and hence we will cross off all other zeros for that subordinate. So let's first do this row wise. So for A we have 1 0, so we'll assign A to subordinate 1. Now 1 cannot be assigned to any other task, so anyways we don't have any other 0 for 1. Now let's move to B. B has 2 zeros, so we'll skip this for now. We'll move to C. We have 2 zeros, so we'll skip this for now. For D we have 1 0, so we'll assign this here. Since subordinate 4 has been assigned to D, 4 cannot do anything with any other task, so we'll cross. Now let's repeat the same steps, but this time we'll go column wise. So for 1 we have already assigned. For 2 we have 2 zeros, so we'll skip this for now. For 3 we have 1 0, so we will assign this here. Now since B has been assigned to 3, B cannot be assigned to anything else, so we'll cross this 0. So proceeding column wise, we'll move on to 4. Here we have either a cross or a 0 assigned. Now let's again go back to row wise. So A already has an assignment, B already has an assignment, C has 1 0 and 1 crossed off, so C is assigned to 2. So this is our assignment. If we note these down, we have A is assigned to 1, B is 3, C is 2, and D is 4. The man hours are 17, 23, 18 and 19, and the total is 77. So with this assignment, overall the man hours taken will be 77.